Okay, so let's not mess about. Today we're going to be proving that the integral of 1 over the square root of 1 minus x squared dx is equal to arcsine of x plus c. Now this is a useful integral to know. Let's just get right into it. So first of all we're going to prove this by differentiating arcsine x. So we're going to let y equal the arcsine of x. We're going to be using implicit differentiation. So we're going to take the sine of both sides. Sine of y is equal to x. And then we're going to differentiate both sides. Implicitly, we get that the cosine of y multiplied by dy by dx is equal to, differentiate with respect to x, we get 1. So therefore, this implies that dy by dx is equal to 1 over cosine y, which is just equal to 1 over cosine of, what was y again? Y was arcsine of x. Cosine of arcsine of x. And here's our result. But this isn't equal to this. At least it's not immediately obvious. We need to do a little bit more work. Cosine of x is equal to the square root of 1 minus sine squared x, because cosine squared x plus sine squared x is equal to 1. Now this isn't always true, because this right here can only take positive values because this is the square root. Whereas cosine x, it can take positive and negative values, specifically between negative 1 and 1. But this is true if we plot the function in question. We're plotting this square root here. We're going to get something that looks like this. It's basically the absolute value of cosine x. And here, we have these points here. Pi over 2 and negative pi over 2. And this does, in fact, match the cosine graph perfectly between these two bounds. And we're taking the cosine of arcsine x here. Now arcsine x can only take values between negative pi over 2 and pi over 2. So for our purposes, within this boundary, these two functions are the same. So let's go ahead and substitute cosine x here for this up here. Yes. So we get that dy by dx is equal to 1 over cosine arcsine x, which is 1 over the square root of 1 minus sine squared arcsine x. Sine of arcsine x is just x, so we get the final answer 1 over the square root of 1 minus x squared. Q E D. Okay, I hope this was helpful. Obviously taking the integral of this will just yield arcsin x plus c, which is what the original function was. This was probably the hardest part. Just understanding that for our purposes, this is a good approximation of cosine x. But I hope that was helpful.